6, which is
Are you serious? How is that not me? Because you still did it.
all right. If you want me to go over it, can you let me go over it? Thank you. 2x squared minus 4x minus 3 and all over square root x. Next, you're about to be the second person to have Karen's phone number in my cell phone, and that won't be good. So if you just go to WhatsApp and copy everybody's work, then you would have half the homework.
Get my name off your mouth, bro.
All right, so
Get my dick out your mouth, bro.
we want to find the tangent line at 4. So what we're gonna do is we're gonna use 4th grade math, and the 4th grade math says 2 over 5 plus 1 over 5 is equal to 1 plus 2 over 5. This is 4th grade math. Is this way, right? But the problem is we can go backwards. We can say, hey, if the bottom is one term, I can split them to 1 over 5 plus 2 over 5. Even though at 4th grade that's insignificant, that's not useful because it doesn't help you add. But in terms of higher level math, it helps you take a derivative because now I can change the format where I can use power rule. But you need to know a little bit of exponent rule as well. So it'd be 2x squared square root x minus 4x over square root x minus 3 over square root x. And that's how you break down to this individual part. Now, you also needed like something like a to the m over n is equal to n roots of a to the m. And you needed this. So, and you also need the exponent rule of top subtract bottom. So it's always top subtract bottom. So therefore, it's going to be y equal to 2x squared. I'm going to convert that. Now, I usually don't do this many steps because I can pretty much do all this in my head, but I want to show you that this where they come from. I haven't taken derivative yet. I'm going to do top subtract bottom. So it'll be 2 subtract 1/2 is going to be 3 over 2. Is that okay? Minus 4x to the 1/2 minus 3x to the negative 1/2. That actually uses negative exponent rule because 1 over n is equal to a to the negative n over 1. So I have used all this algebra to do this question. I haven't used calculus yet. If you realize, I didn't use any calculus at all. Calculus is the easy part, actually. Most of you guys can do calculus, but you cannot do algebra. That's a problem. So if you have y prime, now if you realize I write down all this is y, now I take a derivative. A lot of people thought this is a derivative. This is not a derivative. This is just an algebra to simplify to where I can use power rule. So that's going to be 2 times 3 over 2 times x to the 3 over 2 minus 1, so it'd be 1/2, minus 4 times 1/2 times x to the negative 1/2 minus 3 times negative 1/2 times x to the negative 3 over 2. So that should give you 3x to the 1/2 minus 2 x to the negative 1/2 and plus 3 over 2 times x to the negative 3/2. And this is my derivative. Any question this part? Is this okay? Yes. Did I make a mistake?
No. I just want a question. If you just wanted to find the derivative and that would be our answer, should we keep the negative exponents or put them in like the denominator of each term?
Yeah, that's a great question. I don't need to. I can just plug in as is because my goal is not simplification. I'm not asking you what is the derivative of it. I'm asking you what is the tangent line of it. So I need three things. I need the x value, which is we have, which is 4. We need a y value, which is the y value from the original function. And we needed the slope. So we're going to write down y minus y1 equal to m times x minus x1. This is the equation tangent line. So now we're going to say, okay, well, what is the x? Well, x is equal to 4. We know that. What is y? Means I need to plug in 4 into the original function. So I'm going to go into find out says, okay, well, 4 is going to be 2 times 4 squared minus 4 times 4 minus 3 over square root of 4. I think this one you would end up to get 13 over 2 if you simplify it correctly. I'm not going to teach you how to simplify that, but it's 4 squared is 32. 40 squared times 2 is 32. 32 minus 16 is 16. 16 minus 3 is 13. 13 over square root of 4 is 2. So it's to be 13 over 2. So we know this is 13 over 2. Now the hard part is plugging the slope. So I'm going to say y prime. I can say y prime like this, and I plug in 4. That means I plug in the whatever inside the parentheses is not multiplication. Is to say I'm going to install the x with the 4. So it'll be 3 times 4 to the 1/2 minus 2 times 4 to the negative 1/2 plus 3 over 2 to the 4 to the negative 3 over 2. That's equal to 3 times 2. That's equal to 2 times 1 over 2. That means 3 over 2 times 1 over 8. Because I'm changing the negative exponent first and then do square root and cube. So this is going to be 6 minus 1 plus 3 over 18. So that's going to be 3 over 16, sorry. And that's equal to 5 plus 3 over 16. And that's equal to 83 over 16. So this is 83 over 16. So it'll be y minus 13 over 2 is equal to 83 over 16 times x minus 4. Now, would I ask you equation of normal line? Yes, it'll be 16 over negative 83 if it's a normal line. So normal is nothing to do with normal. Normal is normal force, which is perpendicular in physics. So you have to know if I ask you normal line is opposite reciprocal, but this is the equation tangent line, which is 83 over 16. Any questions? Good. Yes. Number 5. What does number 5 says?
It's a 0.
No, man. H approach 0 or X approach 0?
X approach 0.
X approach 0. Is it H?
Wait, which
Y.
right?
H, bro. H. I said H.
And yeah,
Four radical. No, it's not.
4 radical.
4 radical 9 plus H.
4 radical 9 plus H. Or radical, sorry.
Yes, right.
9 plus H
Oh,
minus 4 radical 9, right?
Yeah. Divided by H.
Divided by H. So this one is definition alternative, definition derivative. Which is in this case, you have to identify looks like f prime of x is equal to limit as h approach 0 of f of x plus h minus f of x over h. So that therefore you know that this is asking what's f prime of 9 is, because that's limit h approach to 0 of f of 9 plus h minus f of 9 over h. So which function you plug in f of 9 is equal to 4 root 9, right? So that means f of x must be 4 root x. Is that okay? I'm going to take a derivative of this, which is 4. This is 4x to the 1/2. So that's going to be 1/2 x to the negative 1/2. And then that's going to give you 2x to the negative 1/2. Now I'm going to plug in 9. So it'll be 2 times 9 to the negative 1/2, which is 2 times 1 over root 9. So it'll be 2 over 3, I think. Is that right?
Yeah.
Yeah. You got it, Paul.
Any questions? No other question? Can we move on? Are you sure? Going once, going twice?
Please move on. Yeah, like just said that. Let's see. Okay, so it's on. So I'm saying, yeah, he starts in this. Yeah, he's like. Because I feel like and you're good on hitting the yeah.
All right, can I move on? All right, so what we're gonna do is we're gonna talk about derivative of sine of x and derivative of cosine of x. Now, I just make sure I'm streaming because I have one viewer.
Yeah. Like, I got you missed it. Well, this match out of the
Okay. All right, so derivative of sine of x and the derivative of cosine of x. Winston, you want to teach this?
Sorry.
Because I want to take a break. Okay. So derivative of sine of x, what we can do is we can use all the things that we learned on the limit section to come up with the derivative of sine of x. Well, first of all, we know definition of derivative. Now, for this part, you don't need to memorize. I just want to show you where the math come from, because the math is where they come from is kind of important. I wish I have time to show you how power rule come from, but I don't have time to do that. But this one I can. So derivative of sine of x is basically saying limits as h approach 0 of sine of x plus h minus sine of x over h. It looks pretty innocent, but we're going to make this more complicated. So first of all, you cannot distribute the sine into the x and h. What are you supposed to do here? Think about here. What can I do here? Using some type of things that we learned in the past. Oliver, what are you saying?
Would be the a plus b when it's like sine of x with the h sine of h with the x.
Yeah, the sum and difference formula, right?
Good job.
So sine, cosine, and then cosine, sine. And I'm going to fill in the x and h. So the x, h, x, h. And that's going to be plus, and this minus sine of x over h. So I'm making this look more complex, but there's only way to get through this. So what I'm going to do is I'm going to change the order to a little bit. I'm going to shift the last two terms to all the way to the front, and the first term move all the way to the back. And the reason why I'm doing that is going to help me with something else. So I'm shifting this two term forward to the front, and this term is all the way to the back. Is that okay? So that's equal to limits as h approach 0, and that's going to be cosine of x, sine of h, minus sine of x, and then plus sine of x, cosine of h, over h. And you're like, why do I do that for? Now remember, when bottom is one term, what do you do? When bottom is h, what can I do?
Distribute it among.
Well, you can, it's sort of not distribute, but we can split, right? Just like what we did earlier, right? So we can say that's equal to limits as h approach 0 of cosine of x, sine of h, whoops, over h right? Oh, sorry. Before I do that, I want to factor out x. Sorry. Let me do this again. So I want to limit as h approaches 0. I want to say cosine of x. Sorry about that. Sine of h. I want to factor out negative sine of x like this. If I factor out a negative sine of x under this term, so I'm gonna get is 1 plus cosine of h over h before I split. Is this okay? Oh, sorry, it's not.
I was wondering why you didn't find that.
And so 1 minus cosine of h. Now I can split them. So cosine of x sine of h over h minus sine of x times 1 minus cosine of h over h. So I'm gonna do something here. I'm gonna do this, and I'm change the green. This is purple, right? And I'm gonna do this part, and I'm changing the green. Do you realize that? Why do I change the green?
The legal one. Sine x over x. Okay.
Lee got it before Andy.
No.
I'm just saying. No, I'm just making fun of. I'm just making fun of Lee.
Yeah.
Sorry, Andy. I'm just making fun of because he's always a pro. I got the same answer as Andy. So sine h over h here is gonna be 1. So it'll be 1 times cosine of x. Now what's the other one? 1 minus cosine of h over h. 0, because remember that was one of the trig limits then. So we use all the things that we know in one questions. So now it becomes cosine of x. So all that work to figure out the derivative of sine of x is equal to cosine of x. You don't have to memorize any of those things. I just want to show you the math coming from all the things you learn and you implement to here, and you actually come up pretty nicely if you do your math correctly. Now, how did people come up with this? I have no idea. They have no life. But so you do have life. So then I'm just going to tell you derivative of sine of x is equal to cosine of x. Derivative of cosine of x is equal to negative sine of x. Now, also, I'm going to give you a hint. Any derivative of cosine of x, cotan of x, cosecant of x, it will result into negative. Always negative. Negative of something. So I'm not going to tell you everything, but it will always negative. See that? This is C, this is negative. They are correlated. They are correlated. So any trig function with a C in the front, if you take a derivative of them, it's always end up to be negative of something else. That's first understanding. Okay, so this is derivative of sine of x. Cosine of x, I can do the definition of derivative again, but I don't want to because I only do it once. You can try how to do the second one, but it's not on the test. This is not on the test. This is on the test, right? This is on the test. You had to be able to do the math. This is on the test, but this is not on the test. But this part here, it will be showing up on the test.
Yeah, when's test?
Next week.
All right. Awesome.
Now, with that being said, I want to review certain things. So the way that you guys study, a lot of time people try to do all the problem and the other thing. The way I study for math or any subject like STEM related search, I study the key points. The key points is what I look for all the time. So, Supper, did you pay attention to this? I just went over how to take a derivative of sine of x. You didn't pay attention to me.
I watched it last night.
What?
Are you sure?
It's in the future, bro.
No, last period. I was here like second period.
What?
Here last period.
Oh, okay. Do you understand it? I didn't think you were paying attention.
Oh, I got
That makes you then. Anyway, I'm gonna study the key point, which is this is all the key points that we have learned. Vertical asymptote is usually the denominator of f of x equal to 0. So if I have a function, denominator of f of x is equal to 0. I'll be really appreciate that. Don't talk while I'm talking because horizontal. I spelled wrong. Asymptote. Horizontal asymptote is the. What is horizontal asymptote? Can somebody tell me? How do I find horizontal asymptote?
By prejudice infinity again.
Limits as x approach infinity. That's the precursor of divided by highest degree of denominator, but you have to approach infinity before you divide highest degrees. Otherwise, you will not go to 0. So then, as you know, you're gonna divide it by highest degree, right? Divide by highest degree of denominator. So of the denominator. Okay, so we know that vertical asymptote and horizontal asymptote. We already did this. But today we would like to introduce you tangent. So what is a horizontal tangent? So don't get confused. So this is why I write down all the key things together. And horizontal tangent. So what happened with horizontal tangent? What do you think horizontal tangent?
Slope to 0.
Slope equal to 0. But Andy, can you tell me in terms of calculus?
The derivative by 0.
Yes. Derivative equal to 0 or f prime of x equal to 0 because derivative are slope. Right? Take a derivative, set it equal to 0. Yes.
Why is that one dy over dx?
dy dx is another way to say it's derivative of y. So there are few notation. Y prime is same thing as f prime of x, same thing as dy dx. This all represents derivative. Okay, so you can say y prime is equal to 0.
Okay.
Now, we got this check. Now, vertical tangent, which is we're gonna talk about later, but we're gonna kind of give you right now, which is vertical tangent is actually the denominator of the f prime of x is equal to 0. Because what? It's also same thing as saying f prime of x is equal to undefined. So if you have denominator, if you have the f prime x has fractions, denominator equal to 0 is going to be vertical tangent because that's going to cause the slope becomes undefined. And slope undefined, then that's it. So we study the key points. Now we're going to give you an example question. We says, hey, y is equal to square root 3x plus 2 cosine of x. And I want to find the x value where f of x have horizontal tangent. Okay, where we have horizontal tangent.
The x outside of the square root.
Ah, that's a great question. Always pay attention. The square root stop right here. That means not including that. So how do we find horizontal tangent again? Set what equal to 0? Derivative. So can you take a derivative?
It's just gonna be square root of 3. And then
Good. Keep on going. Write it down though. Write it down.
I'll write shit down. But
I'm gonna say master. Yes, says write it down.
Sensei,
And then yeah, say right shift there. What time we get off here again?
36.
Huh?
36.
It's
Yeah, and then it's
just take the room instead.
You should get two answers between 0 to 2 pi. Two answers. All right. So the root of y is dy dx. Is that okay? Is equal to what's the root of square root 3x? Square root 3, because that's just the number in front. That's a slope. Remember? Just take a derivative of 3x is 3. Take a derivative of square root 3x is square root 3. Is that okay? What's the derivative of 2 cosine of x? Negative 2 sine of x. Because we learned that derivative of cosine of x is equal to negative sine of x. We set them equal to 0 because that's this. Is that okay? So 2 sine of x is equal to square root 3. Sine of x equal to square root 3 over 2. That's why we learn all the trig value, because now we can use it. When does it, between 0 to 2 pi, when is sine of x equal to square root 3 over 2? Pi over 3? What else? There's choose horizontal tangent. Now what do? Check on decimals. If you check on decimals, it's going to have either maximum or minimum at that point.
It's within the that's not it's just telling you what the ring. Is it not like plus 2 how is yeah, it's not negative product with 3 over
No, because you move it the negative 2 to the other side. You add 2 sine of x on both sides, and you be a 2 sine of x equal to square root 3, and you divide it by 2.
Divided by negative 2.
No, where's the negative 2 come from? Because you add 2 sine of x to the other side. So it'd be 2 sine of x equal to square root 3.
Oh, true. Okay.
Because you do derivative of it, and derivative of x.
Okay, so today's homework, you're going to have some horizontal tangent. Okay? Next thing is I'm going to ask you is this question, which is the hard part of the homework. I'm going to help you question solve 66, but this is 66 says f of x equal to k root x, and the y is equal to x plus 1. So what you're going to do is you have to find the k value where f of x and y are tangent to each other. What do you mean by tangent to each other? That means if I have some type of, wait, hold on a second. It's not x plus 1, it's x plus 4. It's x plus 4. Yes, it's sort of like this, right? They are touching each other. You're right. So I will just graph it to show you here. Now the graph is going to be like something like x plus 4, so it's going to be like this. So this is some type of line. Now you don't have to draw this graph because I want you to do it mathematically. And the kx, the square root x usually look like this, right? But the k is going to influence the curve. It's going to go higher or lower. Okay, so what it's saying is look like this. Okay, so do you see this k? But those at one point is going to be tangent to each other. Do you see that? But at that particular point where the tangent to each other, two things happen. We know the answer is 4, but we need you actually how to find it mathematically. We need you to find it mathematically. So what happened is we know that if this is tangent to each other, if that is going like this, two things happen. First, function equal to each other. Second, the slope equal to each other. Because at that point, the slope is same. And the function is also the same output. So there's two things happen. I usually take care of the slope first. If I take care of the slope, that will be much better. So if I take care of slope, so that's today is f of x is equal to k square root x, and f of and y is equal to x plus 4. I'm going to take a derivative of this. What's the derivative of k root x? Can I rewrite as kx to the 1/2? So what's the derivative of k root x? Yes, 1/2 kx to the negative 1/2. So it'd be 1, so it'd be k over 2 square root x. What'd you say?
Yeah, that looks good. Looks awesome.
So now I'm going to take a derivative of this one because we want a slope of each one. So derivative of that is 1. So can I say, hey, slope equal to each other first? That's the first statement. The second statement's original function equal to each other. So I'm going to show you colors. This is equal to this. Is this okay?
Yeah.
I'm going to start taking care of this part because slope is easier to take it to evaluate value because you got less thing going on. So I'm cross multiply k equal to 2 root x. So I multiply by 2 root x on both sides. I got k equal to 2 root x. I can substitute here, which is k is equal to 2 root x times x is equal to x plus 4. Do you see? What's root x times root x? 2x equal to x plus 4. So therefore, x equal to 4. That's not done yet because we want to solve for k. So let's go back here. K is equal to root 4, and that's equal to 2 root 4, which is 2, which is 4. So first, understand the key thing you study. If you're tangent to each other, slope is equal to each other. Also, the function is equal to each other. Does that make sense? So understand the key points. Because I multiply both sides, so I multiply both sides by 2 root x. So the 2 root x on the 2 root x will cancel out, so k equal to 2 root x.
Okay.
And then I solve for y. So today, this part is that algebra is challenging. Idea is actually pretty simple. If you tangent to each other, that means slope has to equal to each other because derivative has to equal to each other. Then you have to come up with a second statement because you got two variables. You got k and x. You must have two variables to solve. In this case, it's usually better to do a substitution. Okay, so I think Lian was saying substitution is better. In higher degree function that says different type of degrees, like the x squared or square root x, is much easier, bigger, higher level. So usually there is 100% of problem, right? Bottom 80% is elimination. The top 20%, the harder problem, use substitution actually. So most of them, if like say 2 lines, I want to find a system equation with 2 lines that equal to each other, elimination faster, way faster. Way faster. Now, when it's higher degrees, then substitution is better. So you're going to learn how to substitute today. So today's homework is going to be quite a bit of challenge. You're going to have to figure out slowly. I'll post it right after class so that way you can have a head start. It's not hard, but a head start.
It's just the challenging part.
Yeah.